Hello friends, we are back with our next video. In the last video we discussed about mathematics and its fear among the students. In this video we will discuss about a few concepts, tips and tricks on the topic operations on numbers, which is frequently asked in SSC and bank PO exam. I would In this video we will be covering some questions, and I will personally suggest you to stop at each question in the video and first try it yourself. After that you can see what concept I am trying to teach you. So let's start. Our first question is this. It is the most basic and most frequently asked question in the SSC and bank PO exam, but it needs a basic concept to solve this question. The question is, what is the unit digit in 7 raised to the power 105? The answer is this dotted one. That is, the 7 is the answer. First, please try it yourself and then watch the video so that you can know the concept that I think should be applied. Now let's discuss the solution of this question. Believe me, this question is really very good. Now let's discuss the solution. The basic that we used in in the solution of this question is that in the product of two numbers a and b, that is c is equal to a into b, only unit digits of a and b contribute to the unit digit of c. Now let's see what does that mean. For example, a is equal to 34 and b is equal to 43. B is equal to 43 here. Now A into B would be 34 into 43 is equal to 1462. Unit digit of A here is 4 and unit digit of B is equal to 3, and U1 into U2, that is the unit digit of A and B, the product of U1 and U2 is equal to 12. 4 into 3, 12, and the unit digit of 12 is 2, which is same as that of 1462. Same is true for all numbers, whether the numbers are big or small. For example, A is equal to 1, 2, 3, 4, 5 and B is equal to 4, 3, 2, 1. Unit digit U1 is 5, U2 is 1, U1 into U2 is 5, and A into B is also this big number 5, 3, 3, 4, 2, 7, 4, 5, and unit digit is 5. This is very basic. This concept is very basic that we all learn in our schools, but we don't give uh, equal importance with, or we don't use it at all. But this question is based on this. Now this is really basic and we are going to use it in our next step. Let's watch. Now coming back to solution, we have number 7 raised to the power 105, that is 7 into 7 into 7 into 7 up to 105, that is 105 times, and we are starting with this. For example, 7 is multiplied one time, that is only 7, product value is 7 and unit digit is 7. If we consider 7 into 7, that is 7 is multiplied two times with itself, the value result would be 49 and its unit digit is 9. 7 into 7 into 7 is 343 and whose unit digit is 3. Similarly, 7 raised to the power 4, that is 7 into 7 into 7 into 7 is 2401 and its unit digit is 1. Similarly, this is 7 raised to the power 5. 7 raised to the power 5, its value is just 16,807 and its unit digit is 7. Similarly, 7 raised to the power 6, this last one is 7 raised to the power 6 and its unit digit is 9. But as you can see, this is a repetition. 7 is repeated after 4 step here, and 9 is also gets repeated after 4. 1, 2, 3 and 4. This is the another concept that, so what we have observed till now is that 7 will repeat it 4 times after every 4 time, after every interval of 4 you can say. Similarly 9, and similarly 3 and 1, and only possible unit digits in all the multiplications, that is 7 raised to the power something x, only 4 unit digits are possible, that is 7, 9, 3 and 1, and this will repeat after every power of 4. For example, 7, 7 raised to the power 5, 7 raised to the power 9, all will have same unit digit, which is 7. Same is true for others. For example, 7 raised to the power 2, 7 raised to the power 6, 7 raised to the power 10, 7 raised to the power 14, etc. will have same unit digit 9. This is the most important concept that we have used in the solution of this question. Now see here, 7, 7 raised to the power 5, 7 raised to the power 9 have unit digit 7, 7 raised to the power 2, 7 raised to the power 6, 7 raised to the power 10 have unit digit 9. Similarly, there 3, 7, 11 raised powers of 7 have unit digits 3, and 4, 8, 12 etc. will have unit digit 1. After this 4 we have 5 here, then 6, 7, 8, 9, 10, and there are only 4 possible unit digits in case of 7 raised to the power some number x. Now we need to check in which of the above 4 categories, that is first category, second category. First category is 7, second category is 9, third category is 3, fourth category is 1. In which of these 4 categories does 7 raised to the power 105 fall? Now here comes the concept of arithmetic progression. Uh, this I will make a video on this arithmetic progression very soon, and if you know the concept then well and good, and if you don't then please, for now you should learn this concept. This is very basic class 10 standard concept it is. Now see here, it is an arithmetic progression, 7 raised to the power 1, 5, 9, similarly 2, 6, 10, 3, 7, 1. These are our arithmetic progressions. For example, this first one is an arithmetic progression with constant term. This is first term 1 and common difference 4. These all four arithmetic progressions or series have same common difference 7, sorry, common difference 4, and have different for constant term or first terms 1, 2, 3, 4. Now we need to check in which of these 4 does 105 fall. You can write in an arithmetic progression as 105 is equal to a plus 4n, where n is some positive integer and a is any one. A is the first term or the constant term here. So possible values of a's are 1, 2, 3 and 4, and n is a positive integer. We can write 4n is equal to 105 minus a. For n to be an integer, this must be equal to a multiple of 4. As you can see, 105 minus a must be a multiple of 4. For example, for this is because n is an integer and this whole term is equal to 4, and that is a multiple of 4. This is satisfied by a equal to 1. This is satisfied by a equal to 1, and the unit digit corresponding is, as you can see, first term is 1 and corresponding unit digit is 7. So the unit digit is 7 and the answer is 104. I know I took a long time to explain this concept, but I think this is very important to explain it in deep. These types of questions are frequently asked in SSC and Bank PO and other exams, so please pay attention to it. So guys, our answer is 7. Since this question is very important, at the end of the video I discuss similar type of question, so please watch the whole video. If this concept is not clear to you, then I will again discuss this concept at the end of the video, so stay tuned. So our next question is this: which number is nearest to 8485, which is completely divisible by 75? As compared to previous question, this question is quite easy, and the answer is 8475. Please try it yourself first and then look for the solution. The solution is quite simple. If you divide 8485 by 17, you will get x equal to 113.133. Uh, as you can see that clearly 8485 is not a multiple of 75, but we need to find a multiple of 75 that is closest to 8485. For this to get the desired result, there are two numbers possible nearest to x, and the value of x is 113.133. These two possible numbers are 113 and 1114. If you didn't get it, then I chose 1114 and 1113, because if you multiply them with 75, this the resultant the result will be close to 8485, as compared to I choose 112 or 1115. These are two nearest integers, one smaller, that is 113 is smaller than 113.133, and 114 is larger. Now we need to decide which one is closer to 113.138, that is value of x. 113 is closer to x or 114, because the closer number will give the closer multiplied result to 8485. Now to see now to check this, we can do this. 113.133 minus 133 is 0.133, and 114 minus 113.133 is equal to 0.867, and 0.133 is less than 0.867, or it is also common sense to see which one is closer to the result of x by 1, that is 113 or 114. So 113 is closer to x, as it is closer. If we multiply it with 75, it will give a multiple of 8475, which will be closest to 8485. So the answer is A. But note here one thing. In the options, here, one of the options is 8550. It is given so that to confuse you guys, but don't get confused, because if you multiply the another closer number 1114 with 75, the result would be 8550. So this will result into the negative marking. So please do pay attention to choose such closer number in such types of question. Now, as compared to previous question, this question is really very easy. So our next question is this: the smallest six-digit number exactly divisible by triple one. The answer is 1,000,011. I would suggest you to please first try it yourself and then look for the solution. So, we need to first think of the smallest six-digit number. Now we know the smallest six-digit number is 1 lakh, that is 1,000,000. And if you divide it with the given number 111, the result would be, the question would be 900.9009. Now we need to find the number, smallest six-digit number divisible by 111. But if here we divided the smallest six-digit number with 111, that is we divided 1 lakh with 111, and the result is 900.9009. As the result is fractional, this is clearly not our desired answer. Now what should we do? So the simplest thing that we can do is to choose the next integer, smallest integer, greater than smallest integer but greater than that of x. We chose integer because if we multiply it with triple one, the result would be the multiple of 1 lakh. So we choose 901 here, which is the smallest integer but greater than the value of x, 900.9009. Now let's multiply it with 901, and now let's multiply 901 and triple one, and the result is 901 into triple one, 100,011. That is, C is our desired answer. So question number 4 is this: which one of the following numbers will completely divide this expression? This expression looks very weird and scary, but don't worry. So don't forget to try it yourself first. Now let's discuss the solution. Now given expression, or you can say it as a series, can be written as 4 raised to the power 61 into 1 plus 4 plus 4 square plus 4 cube. We didn't do anything new. We did not do anything new. We just took out 4 raised to the power 61 as common. Now the series in the parenthesis, that is this 1 plus 4 plus 4 square plus 4 cube, is a GP, that is geometric progression, with first term 1 and common ratio equal to 4. If you know about what geometric progression is, then well and good, and if you don't know, then don't worry, I will be uploading a video soon, but for now please learn it from other sources. Now summation the summation of the series in the parenthesis would be this value, 4 raised to the power 4 minus 1 upon 4 minus 1, that is 85. So the given series reduces to 85 into 4 raised to the power 61. Now please look at the available options here: 3, 10, 11 and 13. From this we will be able to select our answer. Now look at the expression, reduced expression. The reduced expression is 5 into 70s, that is 85 has been broken into 5 into 17 into 4 raised to the power 60. Now 5 into 4 is 20 and 70 is here, 4 raised to the power 60 is as taken as it is. Now 17 into 2 is 34 into 10, here it is 10, and 4 raised to the power 60 is copied as it is. Now you can see that in the reduced term of the given expression, here we have 10 here, and 10 is also is there in the options, so our answer is 10. But please look at the concept. Here we use the concept of geometric progression. It's summation formula we used here, and then we broken down into simpler numbers so that we can verify from the given options which should be the answer, and the answer here is 10. 2 into 5, 10. And in this you should also see this, that the other numbers which divide the given expression are 2, 5, 17 and other multiples of these numbers. So our next question, question number 5 is: it is given that 2 raised to the power 32 plus 1 is completely divisible by a whole number. Which one of the following numbers is completely divisible by this number? Here we are not provided the whole number, but it is the given information that it has been divided. This number has been divided by a whole number, but we don't have any information here. So please first try it yourself. Answer is this dotted one, 2 raised to the power 96 plus 1. Now let's go for the solution. So the basic formula that I have used there, that struck into my mind once I see the sort of question, is this. This formula is that of 8th standard. A cube plus b cube is equal to a plus b into a square plus ab, sorry, a into a square minus ab plus b square. If you do Please do remember this formula. This formula is really very important, and if you then please also verify this yourself. This one is correct. Now using this, I can write, given one of the options, 2 raised to the power 96 plus 1. 2 raised to the power 96 plus 1 can be written as this: 2 raised to the power 32 plus 1 into 2 raised to the power 64 minus 2 raised to the power 32 plus 1. Don't worry, I am explaining. Here a is taken as 2 raised to the power 32, and a cube would be a 2 raised to the power 32 raised to the power 3. So here a cube is a 2 raised to the power 96, a is 2 raised to the power 32, b is 1, and here a square would be 2 raised to the power 64 minus a into b would be 2 raised to the power 32 into 1, that is 2 raised to the power 32, plus b square, 1 b square, which is 1 square, is 1. Now it can be seen that 2 raised to the power 32 plus 1 is a multiple of 2 raised to the power 96 plus 1, because this 2 raised to the power 96 plus 1 has been decomposed at this. I would suggest you to first look at the options available in all the questions. Of all the questions, this will give you a great hint, guys, uh, as it has done here. 2 raised to the power 96 plus 1 has been decomposed in the form of 2 raised to the power 32 plus 1, and by this we came to know that 2 raised to the power 32 plus 1 is a multiple of 2 raised to the power 96 plus 1, and any number and any multiple of 2 raised to the power 32 plus 1 would also be a multiple of 2 raised to the power 96 plus 1. So the correct answer is D, 2 raised to the power 96 plus 1. So our next question number 6 is this: a number when divided successively by 4 and 5 leaves remainder 1 and 3 respectively. When it is successively divided by 5 and 4, then the respective remainders will be. The answer is B, 2 comma 3. Please try it yourself first and then look for the solution. Now let's start the solution. Let's see the question first. Once again, a number when divided successively by 4 and 5 leaves remainder 1 and 4. Now what does that mean? Suppose there is a number n, it is divided by first divided by 4. This will result into some quotient, that is the left number quotient, and then that quotient is divided by 5. Then the respective remainders are 1 and 4. When the same number n is divided by 5 and its quotient, that is the quotient we get after dividing n with 5, is that quotient is divided by 4, and then we are asked to find the respective remainders. The answer is 2 comma 3. Now let's move for the solution. Now here is a basic concept that you should know. When a number n is divided by some x, then this relation follows: n equal to q into x plus r. This is a class 5th basic concept. N equal to q into x plus r. Q is quotient here, and r is the remainder. It is q into x plus r is equal to n. You can also verify it also yourself for any set, for any possible values of n and x. Now when n is divided by, as given in the question, it is first divided by 4, then it can be, and the given remainder is 1, so n can be written as 4 into n1 plus 1. Here n1 is, here I assume that n1 is the quotient here, so this equation is first, n equal to 4n plus 1. This is followed by this equation, n equal to qx plus r. So now this quotient n1 is again divided by 5, so it can be written as n equal to 5 n2 plus 4. N2 is another quotient we get after dividing n1 with 5, and the remainder that is given in the question is 4. So n1 can be written as 5n2 plus 4. This is the equation number 2. We will use these equations to solve this question. Now using equation 1 and 2, please look at these equations. Here we substituted n1 equal to 5 and 2 plus 4 in equation n1. Please see this, we put n1 equal to 5 and 2 plus 4 from equation 2 into the equation 1, and we get n equal to 4 into 5 and 2 plus 4 plus 1, that is 20 and 2 plus 17, or 5. Here we took 5 common, 5 into 4 and 2 plus 3, 5 into 4 and 2 plus 3. This expression is equal to this expression. You can check it yourself. We broke 17 as 15 plus 2, and then we took 5 as common, so the result is there. Now on comparing this with this result, n equal to 5 into 4 and 2 plus 3. Now 4 and 2 plus 3 is also some integer, because n2 is an integer, so 4 into n2 plus 3 will also be an integer. Now on comparing it with the equation with the relation n equal to dx plus r, we can see that r is equal to 2, that is remainder on dividing n with 5 will be 2, and the quotient in this case will be 4 into n2 plus 3. Now when this quotient is divided by 4, as according to the question is divided by 4, now q is equal to 4 and 2 plus 3, that is if this q is divided by 4, then the quotient will be n2, and the remainder will be 3. You can compare it with n equal to dx plus r, this expression. Again compare it with n equal to dx plus r. If we divide quotient q with n2, the remainder will be 3. So the correct answers are 2, 3. Now look at it once again. We using 1 and 2, we put n1 equal to 5 into n2 plus 4 here. So n reduces to 5 into 4 and 2 plus 3 plus 2. Now on comparing it with n equal to dx plus r, we get the result that if n is divided by 5, the remainder will be 2, and the quotient will be 4 and 2 plus 3. Now this quotient is divided by 4 as given in the question. So here you can see that if quotient q is divided by 4, the remainder will be 3. So the answers are 2, 3, and the correct option is B. So our next question number 7 is, on dividing 2272 as well as 875 by a 3-digit number n, we get the same remainder. The sum of digits of n is. The answer is 10. So do first try it yourself. Now let's move on to the solution. Read the question once again. On dividing 2272 as well as 875 by a 3-digit number n. Here keep in mind that n is a 3-digit number. It is very useful information. And the two numbers that have been divided here are 2272 and 875. Now we are asked to find the sum of the digits of n. Using concept of previous question, 2272 can be written as n into x1 plus r, and 875 can be written as n into x2 plus r. Here r is taken same, r is in the both the equations here, because it is given in the question that remainder are same. Now subtracting first equation is above equation, second equation from first, we get 2272 minus 875, 1397 is equal to n into x1 minus x2. Now as 2272 is a bigger number, is a larger number than 875, its corresponding quotient on dividing it by n, that is x1, will also be greater than x2. So x1 minus x2 will be positive. Here x1 minus x2 is written as x, and x is positive as x1 is greater than x2. Now n can be written as n is equal to 1397 by x. Now the given information that x is a 3-digit number, it is very useful information. We need x should be chosen in such a way that the resultant, that quotient on dividing it, I mean that 1397 is a multiple of x, so that the quotient is a 3-digit number n. I'll repeat it once again. N is written as 1397 by x. We need to choose x in such a way that 1397 is a multiple of x, and the resultant quotient should be a 3-digit number, as the quotient is n itself. Now the x can't be 2 because it is an odd number, and it can't also be divisible by 3. You can verify it yourself. It can all at x can be 4, 5, 6, 7, 8, 9, 10, because in such cases the quotient is not an integer. But for x equal to 11, the quotient is 1397 by 11, 127, which is a 3-digit number, and an integer also. So the n that we required is 127, and the sum of the digits is 1 plus 2 plus 7 is equal to 10. So the answer is 10. Now this question involves this basic concept and the presence of mind. You need presence of mind to choose x, which can only be 11 here, and the useful information in this question was that n is a 3-digit number. As I said in the beginning of this video that I will uh, discuss another question of same type. Now this question number 8 is similar to question number 1. Now this question is, what is the unit digit in 7 raised to the power 95 minus 3 raised to the power 48? Now this question involves two numbers, 7 and 3. In the first question we had only 7. Now we will use same concept, and I will also be explaining that concept again. Now here from the solution of question 1, we had 7 raised to the power 105 there, and here we have 95, so we will change it to 95. Now it can be written as 7 into 7 into 7, 95 times. Now see here, if we 7 multiply 7 with itself one time, that is 7 only, the value is 7 and unit digit is 7. If we multiply it two times with itself, that is 7 square or 7 into 7, the result is 49 and the unit digit is 9. 7 cube similarly is 343 with unit digit 3. 7 raised to the power 4 is 72401 with unit digit 1. 7 raised to the power 5 is 16,807 with unit digit 7, and 7 raised to the power 6 is unit digit 6. Here I'm sorry guys, because the positions of these arrows are wrong, but here you can see that 7 is repeating after 4 and 9 is also repeating after 4. Similarly, if you calculate 7 raised to the power 7, that is 7 multiply 7 times with itself, it is just 7 is happened more time many times, but if you find the 7 raised to the power 7, you will find that its unit digit will be 3, because it will repeat 1, 2, 3 and 4, that is in 7 raised to the power 7 unit digit will be 3. Similarly 7 raised to the power 5 and 7 raised to the power 9 will have the same unit digit 7. Same is the case for others. Now we can write 95 here. It involves the concept of AP. Please do understand it, do learn it, do understand it from other resources. Here 95 can be written as this, where here we have 4 APs. First AP is 159 Please, I show you the answer of question number 1 again. Here it is. Here we have four types of APs. There, first AP is 1, 5, 9, 11, 1, 5, 9, 13. Second is 2, 6, 10, 3, 7, 11, and 4, 8, 12. These have different first terms but same common difference 4. So we can write it as now. Here, here we can write 95 as a plus 4n, and possible values of a can be 1, 2, 3, 4. That is the first term of, actually nth term of an AP can be written as, and we need to find which one of the four APs does 95 belong to. And in question 1 we were finding in which AP was 105 belonging. So here we wrote 95 as this. A can be 1, 2, 3, 4. We can write 4n is equal to 95 minus a. Now 95 minus a should be a multiple of 4n. Should be a multiple of 4, as it is equal to 4 into n, and n is a positive integer. Now if you put a equal to 3, then 95 minus 3 will be 92, and you can see that 92 is a multiple of 4. So the answer is a equal to 3, and the corresponding unit digit corresponding to a equal to 3, that is first term a. So it corresponds to this 7 into 7 into 7, or 7q. So equal to 3 here, and the corresponding unit digit is 3. I know guys, this method looks very time consuming to you, but trust me, I use it personally, and it hardly takes only 1 minute to solve such type of questions using this method, and you don't have to learn any trick. But if you practice such questions well, you will be able to answer such questions in 1 minute only. Now here we are doing repeating same process for 3 raised to the power 58 as we were given in this question. Now I found that the unit digit in 7 raised to the power 95 is here 3. Yeah, corresponding unit digit is 3. Now repeating same process for 3 is, here 3 unit digit, 3 is multiplied one time, unit digit is 3. 3 into 3 is 9, so unit digit is 9. 3 into 3 into 3, 3 cube is 27, and unit digit is 7. 3 into 3 into 3 into 3 raised to the power 4, 81 is 1, unit digit is 1. And 3 raised to the power 5 is, its value is 243, and its unit digit is 3. And similarly, you can see that 3 is repeats itself after interval of 4, and 9 repeats itself after interval of 4, and similarly. And the only four possible unit digits possible for any exponent of 3, that is for any 3 raised to the power n, whatever the value of n is, there can only be four possible values of unit digit, which are 3, 9, 7, 1. In case of 7 it was 7931, and in case of 3 it is 3971. Now we need to and here again, here are APs. First AP is 159, second is 246, third is 37. Same AP is same here as in question number 1, or in the case of 7 here. Now we need to find which AP does this 58 belong to. Again we repeat the same process. 58 is equal to a plus 4n. We need to find n, we need to find a, so that the 58 minus a is a multiple of 4. So a can be written as, now if you choose a equal to 2 here, 58 minus a will be 56, which is clearly a multiple of 4, which follows that n equal to 14. Now though, so the possible value of a is equal to 2, and the corresponding unit digit, here you can see corresponding unit digit, this is the second decimal line, corresponds to a equal to 2, and the unit digit is 9. So the unit digit is 9. Now the unit digit of, the unit digit of 3 raised to the power 58 is 9. Now the unit digit of this expression 7 raised to the power 95 minus 3 raised to the power 58 is 3 minus 9, 4. Now unit digit is 3 and unit digit that of 7 raised to the power 95 is 3 and that of 3 raised to the power 58 is 9. Now if you subtract 3 with 9, of course there will be a number, xxx here and some xxx. I mean, it is not necessary that it is a 4-digit number, but what I'm trying to say is that there is some number in the left of 3, from which we can take carry 1 carry, and this will return to 13, and 13 minus 9 is 4. So the correct answer is 4. So guys, please if you didn't understand it, then please try it yourself and watch again, watch the video again, so that you can understand the concept, because this question is really very important and emphasizing on it. So guys, at the end of the video I am giving you a set of practice questions so that you can practice on similar types of questions that I've just discussed. Here are 5 questions in this slide and another 2 questions here on this slide. So please guys, solve these questions and do comment do comment about the video so that I can get the feedback. And if you like the video, then please like, subscribe and share